Hi, welcome to Dr. Pat TV. In a previous video, we learned how to evaluate functions. That just basically means plug in the letters or the numbers and then calculate with the formula. And so this time we're taking it a step further. We're raising it a notch, or oh man, we're extending the understanding here. All those kind of phrases that saying we're making it harder. Okay, so here's what we're going to do. What we have here is we have this fraction here. If you're familiar with this, this is actually just the way we do slope. Change of y's over change of x's. This function notation, this f parentheses 3, just means the y value at 3, the y value at 6. We take the difference there. That gives us the change in y values over the change of x values. We've got slope. So that's all we're playing with. Right now in pre-calculus, we're learning how to evaluate these things. When we get to our calculus class, we're ready to crunch these puppies out, and we'll find out that that's called rate of change. It's called slope. But for right now, let's just evaluate these things. Okay, so how do we do this? Here's some steps for us. First thing we want to do is calculate with 6. We're going to take that 6, plug it into the x right there. We're going to replace that x with the 6, and then we'll calculate it out. And we'll use that result, whatever result we get, we're going to replace this whole f of 6 with that result. Then we go over here to the f of 3, we take that 3, we go up there, we plug it in for the x, and then we calculate. So we're calculating with 3. Next step we do is we subtract. That's what the minus sign's there. So we're going to find two results there. We're going to take the difference of those things. And then our last step, let's divide that 3. So that 3's down there in the denominator, ready to do the division. Okay, so let's take a look at see what happens here. So we're doing the difference quotient here of this f of 6 minus f of 3 over 3. We've got our formula 4x squared minus 7, and now basically we just need the results to work the top, the numerator. So we're plugging in 3 into the original formula. You see that 3 right there. We then do the calculation, so 3 squared times 4 minus 7. You crunch that on your calculator, you get something like 29. Next thing we got to do is figure out what's this f of 6? What's the result when we take 6, plug it into the formula? So when we do that, I take that 6, plug it into the formula. Once again, 6 squared is 36 times 4 minus 7. Crunch that out on your calculator, you're going to get something like 134. Okay, so what we have right now are the results when we plug in 3 and the result we get when we plug in 6. Those are our results. So now we take this 134, we go back up to this f of 6 and we replace it. We take this 29, go back to the f of 3. The whole f parentheses 3 thing gets replaced by the 29. And so that's what we've got here. So where I see f of 6, I now have the 134. F of 6 just says, what's the value we get? What's the result we get when we plug in 6? Well, we get 134. What's the result when we plug in 3? We get the 29. So that now that I've got my results, I'll use the results instead of that notation. And so the next step, take the difference on top there, that's 105, and then divide by 3, and we get a result of 35. So what we have here is this difference quotient, this rate of change between 3 and 6. When we do this calculation, our result is going to be 35. Okay, let's take here's a couple more problems for you to do, some difference quotient practices. Okay, and so we'll have these. We're basically working the same formula, the 4x squared minus 7, and what we're going to do is the difference quotient for this f of 3 plus h minus f of 3 over h, and then also the very general f of x plus h minus f of x over h. So this is the very general difference quotient. This is the one with just the letters, man. No numbers and things like that. So we're making kind of a transition there. We first did an example with all numbers. Now we're kind of doing a combination of numbers and letters, and then the last one's just going to be pure letters, pure variables. Okay, let's see what this is going to look like. We first have to get the what's the top, the results for these two pieces, the top of it. So we're going to take that 3, we're going to plug it into the equation and then crunch it out. We got that 29. So that's the same result we got earlier. So that's kind of nice. Then we got to work this 3 plus h. So that means where we see an x over here in the original guy, we're going to plug in 3 plus h. Now, because this thing is inside the parentheses to the power 2, that means we got to expand that out. That's 3 plus h times 3 plus h. So go back and take a look at your algebra skills on that one. When we expand that out, I'm going to get 9 plus 6h plus h squared. Going to have to multiply that thing by a 4 and each of those pieces and then subtract by 7. So 4 times 9 is going to give me 36 minus the 7. That's where this 29 is coming from. 4 times 6 for the 24 and then 4 times the h squared for 4h squared. So that's the result of the first part here. So where we see this first top left hand part of the fraction, we're going to replace it with this result of 29 plus 24h plus 4h squared. And that's what we've got going on here. So I'm taking the top left, putting its result. The f of 3, putting in the result of 29. And now we just got to work the top here. And so when we work the top, we'll cancel out the 29s, and that'll leave us just the 24h plus 4h squared. And then if you're looking at this, you're noticing, hey, dude, we've got h's everywhere. And as long as each term has an h, we can reduce out an h. So I can take out an h out of the 24, take an h out of the 4h squared, and take this h down here and make it a 1. So kind of reduces out the fraction. So there's the 24. That becomes a 4h. And we are done with this problem. This is our result. This is the result we get when we do this difference quotient. When we plug in the 3 plus h, plug in the 3, and do all that calculation. Okay, we've got one more example and then we'll finish this up here. And so this is, again, the more general one, but we follow the same steps. I got to find out what the results we get. What are the formulas when we work the top? So our first one here is f of x. Well, that's really easy. I don't have to do a thing because I got an x there, plug an x there. It's the same formula. I don't have to do anything. So that one's ready to go. We have this second piece ready to go. It's this f of x plus h that we've got to work. But that just basically says take the x plus h, plug it in for the x, and then expand this puppy out. That's an x plus h squared. That means x plus h times x plus h. Do that FOIL thing if you like it that way. And this is when we expand that out, I get x squared plus 2xh plus h squared. Got to multiply the 4 through, and then that's what I've got there. So 4 times x squared, 4 times 2 for the 8, 4h squared there, and I still have that minus 7 coming along for the ride. Don't forget that. Now we've got the results. We can take this f of x here, replace it with the original function, 4x squared minus 7, and then we can take this whole package deal, these 4 pieces there, we'll replace the f of x plus h. And that's what I got here. So I'm just taking the results that we have and I'm replacing the notation with the results. And you're going to see that the 4x squareds cancel, the 7s cancel. That's going to leave us this stuff in the middle, kind of like before. And noticing we've got h's everywhere. Both terms on top have an h and an h on the bottom. We could reduce it out. Everybody gets reduced. H gone for the 8x, and h is gone from the 4h squared, so that just leaves us a 4h, and we are done, and that's our difference quotient. That's our result. So hopefully this makes sense. So we're using our function notation with something called the difference quotient, which is basically a very sophisticated rate of change. Thanks. Have a good one.